Okay, moving on to question 4, we have been told that show this equation tan theta plus 60 degrees is equal to 2 cot theta can be written in this form. So actually, the way we have to solve this is using trig identities, and these are the ones given in your formula sheet, which I have pasted over here. So the one we need to use is this one. So let me just write it down for you over here. We will use tan a plus b is equal to tan a plus tan b over 1 minus tan a tan b. So we have been given tan theta plus 60 degrees. So if we write that in using this identity, we will have tan theta plus tan 60 degrees over 1 minus tan theta tan 60 degrees. Now, what is the value of tan 60? So we could put it in the calculator, but instead we need to know the exact value. So you should know that tan 60 degrees is root 3. Actually, you should know the values of tan 30, 45 and 60 degrees. This would help you do your paper more faster and efficiently. So we can now rewrite this as tan theta plus root 3 over 1 minus root 3 tan theta. Okay, now that is the left hand side of the equation. About the right hand side of the equation, we should first know what is cot theta. So cot theta is actually 1 over tan theta. So now let's use this information and plug it into our equation. So 2 cot theta would be 2 over tan theta. Now if we write this down again, we will have the left hand side as tan theta plus root 3 over 1 minus root 3 tan theta, and the right side would be 2 over tan theta. And now we will just cross multiply. So tan theta times tan theta would be tan square theta plus root 3 tan theta is equal to 2 minus 2 root 3 tan theta. And if we do some rearranging now, we will have tan square theta plus root 3, and this will become plus 2 root 3. So that will be 3 root 3 tan theta minus 2. This 2 will come on the other side and become negative. So equals to 0. And that is this form that they asked. So it is shown. So for part B of this question, we have been told hence solve this equation. And whenever we know that they've said hence, that means we have to solve it using part A. And in part A, we realize that this can be written as tan square theta plus 3 under root 3 tan theta minus 2 equals to 0. So to make our lives easier, we usually let u is equal to tan theta. And we can rewrite this as a regular quadratic equation. So it would look something like this. And now we're going to consider this as A, this as B, and this as C, and solve it using our regular quadratic equation. So it's going to look like u is equal to minus 3 under root 3 plus minus under root 9 times 3 minus 4 times 1 times minus 2, and the whole thing divided by 2. So if we simplify this, that is going to be u is equal to minus 3 under root 3 plus minus 27 plus 8. So under root 35 divided by 2. So u is equal to minus 3 under root 3 plus under root 35 divided by 2, or u is equal to minus 3 root 3 minus root 35 divided by 2. And in decimal form, this would be u is equal to 0.35996, or u is equal to minus 5.5561, which we will find out by using a calculator. But remember that we let u as tan theta. So now we will change the value back and say that tan theta is equal to 0.35996 and tan theta is otherwise equal to minus 5.5561. Okay, so these are our two options. So let's see what this would look like on the graph. So we know that we have 4 quadrants, A, S, T, C. Here in the first quadrant, everything is positive, in the second sine is, in the third one tan is, and in the fourth one only cos is positive. So since we have a positive value, we are going to have this value in the first quadrant, and we know that tan is only positive in the first quadrant and the third quadrant. But we should remember that our range is only from 0 to 180 degrees. So we are only looking at the top 2 quadrants, and we will not be looking at the third or fourth one. So this is useless to us. And if we look at the second formula and draw that, tan is negative. So A, S, T, C. And we know that tan is only negative in the second and fourth quadrant. So once again, we're going to see that we're only looking from 0 to 180 degrees. So this is going to be completely disregarded. Now, let's actually solve for theta. And if we do tan inverse we had theta is equal to this value. So yes, theta is going to be tan inverse 0.35996, and if you put that in the calculator, you get theta is equal to 19.8 degrees. And since we're only looking at the first quadrant, this is going to be our only answer. Now, for this second option, we will do theta is equal to 180 minus x, and we only use this trick because our particular value for theta is negative over here. So whenever we're finding negative, it's just easier to find tan inverse of this same value but positive and then minus that from 180. So we're going to do theta is equal to 180 minus x. So first we will find x, which will be tan inverse the positive value, and if we put that in the calculator, we get x as 79.8, and so theta will be 180 minus 79.8, which will be 100.2 degrees. And so our values for theta that we solved will be 19.8 degrees and 100.2 degrees.